Data centers are overheating, literally, and economically. AI training runs guzzle megawatts, dump oceans of heat, slam into grid limits. So what if I told you the next great data center won't be on Earth at all? It'll be above the clouds, sipping endless sunlight, radiating heat into the cold of space. Welcome to Project Suncatcher and the race to space-based compute. Here's the shock. We're not waiting decades to test this. Google plans tests in 2027 with Planet Labs, 2 test satellites, each carrying 4 TPUs, AI chips, networked together like a tiny orbital data center. The aim? Prove satellites can act like a high-bandwidth cluster in nearly continuous sunshine. In the right orbit, solar panels can harvest up to 8 times more energy per year than on mid-latitude Earth. That's 24/7 power, no clouds, no night. Cooling is the other breakthrough. In space, there's no air, so you radiate heat into the cosmic freezer. Passive, predictable thermal control, without water towers, without chillers that weigh down Earth facilities. But can chips survive space? Google blasted its latest Trillium TPU with a 67 MeV proton beam to mimic years in orbit. The results are promising, though memory components proved most vulnerable to radiation. Can satellites communicate fast enough to function as one unified computer? Early demonstrations achieved 800 Gbps in each direction between prototypes. Multi-terabit interlinks now appear feasible. Picture AI chips in server racks. But the rack is a 1-kilometer cloud of satellites, meshed together by tight beam optical links. Google has sketched an 81-satellite cluster concept for distributed orbital computing. They acknowledge that designs could change significantly and huge technical hurdles remain. What about cost? Current launch prices sit around $1,500 to $2,900 per kilogram, still too high for economic viability. If launch costs drop below $200, possible by the mid-2030s, launching and operating a space data center could become cost-competitive with Earth-based facilities' total operating expenses. Remember, the sun never sends a power invoice. And it's not just Google. Jeff Bezos envisions gigawatt-scale space data centers within 10-20 years.
One of the things that's going to happen in the next, it's hard to know exactly when, it's 10 plus years, but I bet it's not more than 20 years. We're going to start building these giant gigawatt data centers in space.
Elon Musk and SpaceX have also signaled interest in orbital data centers, among others. Everyone feels the pull of the sun. Here's the challenge. AI is hitting a wall on Earth. Power constraints, cooling demands, grid strain. Space flips the equation entirely. Abundant solar energy, passive cooling in the vacuum of space, and global reach without ground infrastructure. The 2030s could be the decade space compute becomes economical as launch costs continue declining. Will it be easy? No. Radiation hardening, debris avoidance, satellite servicing, and tight beam networking at scale all present real challenges. But physics is on our side. A cold vacuum for heat rejection, a massive fusion reactor 93 million miles away, and launch costs trending steadily downward. AI needs a new frontier, and space may be closer than we think. Fascinated by space solutions to Earth problems? Like and subscribe for more cosmic insights from Cosmos Report.